Hey guys, so this is a quick review of doing different types of angles as they intersect, or different types of lines as they intersect. So the different types of angles that are created by two lines intersecting. The first type of angle that's created is something called corresponding angles. Corresponding angles would be found in examples like numbers 1 and 5. Okay? Also in examples like, let's say, 2 and 6 would be corresponding. So looking at like the top right corner of each of these, if that makes any kind of sense. All right? So we just said angles 1 and 5 were corresponding. Angles 2 and 6 were corresponding. We would also have angles, what else?
4, 8.
4 and angle 8 would be corresponding, and angle 3 and 7 would be corresponding. Okay, so far? And so something that I touched on before was if I knew that these lines were parallel. Okay, let's say if I knew this was parallel to this line, corresponding angles are useful to me because as soon as I know one of these guys, little flashy line. Okay, so as soon as I know one of these guys, like this one here, then the corresponding angle is going to be 5. And let's say that I knew that angle 1 was, let's say, 40 degrees. If I knew angle 1 was 40 degrees, that would mean that the corresponding angle would be congruent. So angle 5 would also be 40 degrees. That's how corresponding angles work when I have parallel lines. Okay? And so then angle 1 and angle 2 would be supplementary. So if this is 40, then this over here would be 140 is correct. Okay? And then the corresponding angle to 2 is what?
140.
Angle 6, which would also be 140. Okay? And then we also know that angle 8 would be what? If 6 is 140, then what we know angle 8 is going to be?
140.
140 because of what different property? Vertical angles, very nice. And then I could say 8 and 7. What's 7 going to be?
40.
40 because of what?
Vertical angles.
Either vertical angles from angle 5 or
Linear
a linear pair right there, or a linear pair right here. Okay, great. G-R-E-A-T. You guys are awesome. Yay for the. Okay, so, all right. You're very welcome. All right. After that, we have something called alternate interior. So we have alternate interior. Alternate interior angles would be, let's say, a different color, would be angle 4 and angle 6. Notice that they are on the interior of these two lines. That tracked really well. Okay, so we have they're on the interior of those two lines, and so we have angle 4 and angle 6 are alternate interiors. And then what's the other alternate interior that we see there?
Angle
3. I'm keeping you guys on the edge of your seats. Nice. Angle 3 and angle 5. Okay? So, and if we knew that these were parallel, okay? If we knew that these were parallel lines, then angles 4 and 6 would be congruent. Angles 5 and 3 would also be congruent if we knew they were parallel. And that's a big if. We would have to know that. All right? So that's alternate interior. So as opposed to being alternate interior now, we can also have alternate exterior. All right? And so I would ask, what would be on the exterior? All right? What would be on the exterior of these two lines?
1.
You can't whisper it, sorry. What was it? What was 1 and?
7.
1 and 7, so angle 1 and angle 7. And?
Angle 2 and 8.
Angles 2 and 8. All right, so these are angles. And so if that's the case for each of these, then if I knew, once again, if I knew these were parallel, then my alternate exteriors would be congruent. 7 would be congruent to angle 1, angle 8 would be congruent to angle 2. Okay? So those are my alternate exteriors. And then the last one that we have is called consecutive interior angles. Okay? Consecutive interiors would be 4 and 5, or numbers 3 and 6. All right? That's consecutive So consecutive interiors would be 4 and 5, angle 4 and 5, and angles 3 and 6. In these cases, notice that I have an acute angle and I have an obtuse angle. The two of those would add up to 180 degrees. They'd be supplementary. If these were parallel. That's the big if. All right? And then 3 and 6 also would be supplementary and therefore add up to 180 degrees. Okay?
Okay.
Another thing that I have not mentioned is that this line that bisects the two... I'm sorry, did I miss you on something?
I'm so confused. Okay. Wait, I got it.
You sure?
Yeah, I'm positive now. Sorry, I just kind of got lost for a second, but then I realized what it was.
Okay, I was moving pretty quick.
Okay. I
You good?
understand now, yeah.
Okay,
Just
great.
sit down and think about it.
All right. Nope. Okay, so what was the? Oh, so if I have these, if I have two lines like this, and then I have another line that's like cutting through it, this is called the transversal. I ran out of space. I did that to myself. This is called the transversal. All right, out of the space. All right, so that's called the transversal. Okay, that it cuts right through. Nothing special happens. It doesn't like bisect anything. It doesn't hit midpoints automatically. It can, but it's not implying that. All right. So the transversal just cuts through two other lines. Okay. All right. We also quickly discussed the idea of parallel and skew lines. All right. So we know two lines are parallel. Back in the day in algebra, we knew two lines are parallel if they shared the same.
Triangle, arrow.
Back in algebra, if they shared the same
Congruent angle.
slope. All right, slope. All right, remember the y equals mx plus b?
Yeah.
We knew that two. Huh? Oh, girl, we got a whole lot of that. All right, if the slope is congruent, then we knew that those lines were parallel. That's how we did that, like last year. Okay, and so. And we will continue to do this year. So if they have the same slope, then they're going to be parallel. All right. Now, we also have something called skew lines, which is going to be really hard for me to draw on a two-dimensional plane. But let's say that this was let's say we had a plane right here, and I've got these two parallel lines. This is line L for line and LM. So lines L and M are parallel. They will never intersect. Yay! But let's say I had a line that was three-dimensional and it was shooting out of, let's say it was coming out of the wall, like shooting at, I don't know, shooting at me, like that, was then having to jump back and dodge it. It was great on a two-dimensional surface to show it. Okay, like if I showed like a pencil ripping out of the whiteboard, like coming at you, all right? And it started from this point right here, and all of a sudden, doo! This line would be called skew. Because the line that's shooting out, the pencil that's shooting out of the board, is never going to intersect line M, and it's never going to intersect line L. Okay? Because it's just shooting straight out. Okay? It intersects the plane, but it is not contained within the plane. Is that okay?
Mm-hmm.
Yeah?
Kind of makes the sound skew, like skew.
That's right. Okay, those are basic ideas right there. And I'm going to stop this little infomercial. And yeah.
Brought to you by
Bye,
Shahkar.
family. Love you, Grandma.